In Lesson 3-4, we will discuss exponential and logarithmic equations. In video 3.4.6, our learning target will be for students to be able to solve exponential equations. In example 6, we're asked to solve exponential equations in quadratic form. Now, one thing we can do is we want to solve this quadratic. Now, the book uses a substitution to help us solve this quadratic. So what they do is they say, let u equal e to the x. Thus, u squared, if I squared both sides, then I would say u squared is u squared. If I square e to the x, that's e to the x quantity squared, and by using my power properties, a power raised to a power means I multiply, so I would get e to the 2x. U squared is e to the 2x. Well, by making a substitution in this quadratic up here for e to the 2x and e to the x, e to the 2x is u squared, e to the x is equal to u, so I have u squared minus u minus 2 is equal to 0. The whole point of this substitution is to help us solve this quadratic equation. By taking the e to the x and the e to the 2x out and rewriting it as u squared minus u minus 2, it makes it easier for us to solve this quadratic by factoring. So I'm going to go ahead and factor this quadratic, and I get u and u, because u squared, u times u is u squared. I want to multiply two numbers that give me negative 2, but also add to be negative 1. Since my product is negative, I know this will be a plus and a minus. And if I'm going to multiply to be negative 2 and add to be negative 1, it must be positive 1 and negative 2. Positive 1 and negative 2 added together give me negative 1. So I'm going to use the zero product property here. This factor times this factor is equal to 0. Means that one or both factors have to equal 0. So by setting each factor equal to 0 and solving for u, I get u equals negative 1. And over here, I get u minus 2 equals 0. So I get u equals 2. Now, what I can do now that I've used my u substitution to help me factor, I can go back in and substitute for u. So I get e to the x equals negative 1, because I can resubstitute for u. U is the equivalent of e to the x, and u equals 2 over here, so I would get e to the x equals 2. Now, what we need to do here is figure out the solutions for x. And so on the next slide, I'm going to go ahead and solve these exponential equations right here for x, and then check my solutions. By solving e to the x equals negative 1, in order to solve, e to the x equals negative 1, since I want to solve for x, I'm going to take the logarithm of both sides. Since my base is e, I'm going to use natural logarithms to solve this exponential equation. So I'm going to go ahead and use the natural log, or take the natural log on both sides of my equation. Now we know that natural log of e is equal to 1, and that I can use the power property of logarithms to bring the x out in front. So I get x times natural log of e is equal to the natural log of negative 1. Natural log of e is equal to 1, so I get x equals ln of negative 1. Now, if you try to evaluate natural log of negative 1 on your calculator, it'll say error. That's because you have to have an input greater than 0 to evaluate a logarithm. Because exponential functions have a range greater than 0 of y greater than 0, then the domain of a logarithmic function has to be greater than 0. So therefore, a natural log of -1 does not exist. So we say no solution to that part. Or we would say extraneous. We would say no solution if this was our only answer or exponential function we are going to solve, but we still have to solve e to the x equals 2. So there's no solution to natural log of -1. That doesn't mean that the entire answer to the entire problem is no solution, because we still have to solve e raised to the x equals 2. So I'm going to go ahead and take the natural log on both sides. Again, because my exponential function is base e, and natural logs are base e, so that makes it easy for me to simplify. I'm going to use the power property here, bringing the x out in front. X times natural log of e is equal to natural log of 2. Natural log of e is equal to 1, or you could say natural log and e cancel out because natural log is base e. And anytime your base of your logarithm and your input are equal, they cancel out and leave you with 1. So 1 times x is just x, and x is equal to natural log of 2. So on my calculator, I'll go ahead and evaluate natural log of 2. And I get an x value of 0.693. Now, there was no solution to our first part here, so this was like an extraneous solution. X equals 0.693 is our actual solution to this problem. In guided practice, example 6, I would like you to solve the exponential equation in the quadratic form e raised to the 2x plus e to the x minus 12 is equal to 0. You have 4 choices here for solutions. I would like you to go ahead and solve this quadratic equation and find the solutions or values of x, and then press submit when you find your answer.